Hi everyone. In this lesson, we're going to learn how to approximate the value of an irrational number. But before we do that, we're going to learn how to determine if a number is a perfect square or not. So let's look at this list of perfect squares. So let's look at the number 1. Is number 1 a perfect square? So if this side is 1, this side is 1, 1 times 1 is a perfect square. It's 1. What about 4? If this side is 2 and this side is 2, 2 times 2 is 4, so 4 is a perfect square. What about 9? This side is 3 and this side is 3, 3 times 3 is 9, 9 is a perfect square. What about 16? If this side is 4 and this side is 4, 4 times 4 is 16. Okay, so by now you can tell if 25 is a perfect square. It is because it's 5 times 5. 36 is a perfect square because it's 6 times 6. And 49 is a perfect square because it's 7 times 7. Each side length is 7. So 7 times 7 is 49. That's a perfect square. 64 is 8 times 8. 81 is 9 times 9. So all these numbers are perfect squares. And these are just some numbers that are perfect square. The list is very long, okay? But I wanted you to be able to recognize when you are given a perfect square number. All right, now let's look at these numbers here and determine if they are perfect squares. So let's look at 6. Is that a perfect square? Well, if you said this side is 3 and this side is 3, which gives us a perfect square, but 3 times 3 is not 6. 3 times 3 is 9, so 6 is not a perfect square. 6 is not a perfect square. Okay, well, let's try 8. What do you think? Is 8 a perfect square? So if you said this side is 4 and this side 4, well, 4 times 4 is not 8. It's 16, so 8 is not a perfect square. All right, what about 12? If you said this side is 6 and this side is 6, well, 6 times 6 is not 12, it's 36. So 12 is also not a perfect square. So I hope this exercise helped you determine if a number is a perfect square or not. Okay, you'll need to be able to do that for this next exercise. Right now, what we're going to do is learn how to approximate the value of irrational numbers. And we are going to follow these 4 steps. 1, 2, 3, and 4. All right, let's start with number 1. We want to approximate the value of the square root of 5. So, step 1, find the 2 perfect square roots the irrational number falls between. So, the square root of 5 falls between the square root of 4 and the square root of 9. That's step 1. Step 2, determine the 2 whole numbers the irrational number is between. Well, the square root of 4 is 2, and the square root of 9 is 3. So the square root of 5 is between these 2 whole numbers. But exactly where? Okay? That takes us to step 3. Determine the number of units the irrational number is away from each number. All right, so 5 is how many units away from 4? 1. 5 is how many units away from 9? 4. Okay? We know square root of 5 is between 2 and 3. We know it's not 2.5. We know it's not 2.5. Because if it was 2.5, these numbers have to match. They have to be the same. They are not. We know it's less than 2.5 because the square root of 5 is only 1 unit away from 4. It's closer to 4. So that may put us at an approximation of 2.2. Okay? So maybe it's 2.2. let's check and see how good this estimation is. Let's take that number and multiply it by itself and see how close it is to 5. 2 times 2 is 4, 4, 4, and 4. So 4.84 is only 0.16 units away from 5. Maybe we can get closer. We can try 2.3 and see if that'll get us even closer. Okay, so this one here is 0.16 units away from 5. This one is 0.29 units away from 5. This one is actually closer. So we're going to go ahead with this estimate. We're going to estimate it at 2.2. Okay, so let's do the next one. We're going to repeat the same steps. So the square root of 13, step 1 is between the square root of 9 and the square root of 16. Square root of 9 is 3. The square root of 16 is 4. How many units is 9 away from 13? It's 4 units. And how far is it from 16? It's 3 units. We know it's between 3 and 4. And we know it's not 3.5 because these two numbers are not the same. Okay, so the square root of 13 is not equally distant from square root of 9, square root of 16. We know it's closer to 16. It's only 3 units away. Okay, so it's more than 3.5. So let's approximate it at 3.6. Let's multiply that by itself and see if that's a good approximation. 6 times 6 is 36. 3 times 6 is 18, plus 3 is 21. 3 times 6 is 18. 3 times, carry the 1. 3 times 3 is 9, plus 1 is 10. So we get 12.96. That's pretty close to 13. We don't have to do any more work. So the square root of 13 is approximately 3.6. All right, why don't you pause the video and try the next one on your own and then come back and check. All right, I'm going to continue. Square root of 22 is between these two, square root of 16 and square root of 25. Square root of 16 is 4, square root of 25 is 5. It's 6 units away from 16, and it's 3 units away from 25. We know it is not 4.5 because these two are not equal. We know it's closer to 25, so we know it's more than 4.5. So maybe we can say 4.6. Or even 4.7. Let me try 4.7. I think that's a better estimate. I mean, we could go with 4.6 and check it, but I think 4.7 would be a better estimate. So 4.7 times 4.7. Let's see what we get. Okay, so we end up with 22.09. That's very close to 22. So our answer is approximately 4.7 for the square root of 22. All right, pause the video, try some of these problems, and come back and check. I am going to continue. Square root of 32. That's between the square root of 36 and the square root of 25. This is 5. This is 6. 7 units away from here. And it's 4 units away from here. We know it's not 5.5 because that's in the middle and these two are not equal. It is closer to 36. It's only 4 units away. So we know it's more than 5.5. We can try 5.6. Let's see if this is a good estimate. Multiply it by itself. All right, so that gives us 31.36. So we're 0.64 units away from 32. Let's see if 5.7 would be a better estimate. Okay, so 32.49, we're 0.49 units away from 32. So what we can do, so that we're closer, but we're not over, we can take 5.6, instead of 5.6, we can take 5.65. So it'd be a lot closer than this, but it'd be a lot less than this. So about 5.6 would be a good estimate. So this is approximately 5.65. Okay? All right, let's look at the next one. Square root of 52. And that's between the square root of 64 and the square root of 49. This is 7. This is 8. It's 3 units away. It's 12 units away. Okay, we know it's not 7.5. We know it's not that because these two are not equal. We know it's a lot closer to 49. It's very close. So maybe 7.2 would be a good estimate. So let's multiply that by itself and see if that's a good estimate. All right, so 51.84, that's a pretty good estimate, and I think we'll go with that. So 7.2, approximately. All right, let's go ahead and look at the next one. Square root of 47. It's between the square root of 49 and the square root of 36. So this is 6, and this is 7. It's 11 units away from 47, and this is 2 units away from 47. So we know it's not 6.5. We know it's not 6.5. Okay? We know it's more than that because it's closer to the square root of 49. So let's say maybe 6.8. I'll see how good that is. 6.8 times 6.8. And that's going to give us 46.24. If we do 6.85 to try to get closer, if we multiply that out, that's going to give us 46.92, which puts us very close to 47. So that's a good estimate. So around 6.85. All right, so if you notice that 6.85, okay, is a little less than you would like, then you could go ahead and increase that by 0.05 of a point, like I did here. Okay, and then you can try that. All right, let's go ahead and go to the next page. All right, so go ahead and pause the video, work these problems out, and come back and check your answers. All right, so if you got a chance to do these, okay, now I want you to check. So I'm going to give you the approximation that I have for each one. This is approximately 7.1. If you got something in that neighborhood, then you're good. This is approximately 8.3. This is approximately 5.6. Your answer may not be exactly like my answer, but if it's in the neighborhood, if it's close enough, then you're good. Remember, this is an estimation. This is approximately 9.4. This is approximately 4.45. This is approximately 3.7. Okay, hopefully you did a great job. All right, moving on. Here on this page, we're given two numbers and we have to compare them using less than, greater than, or equal to. All right, so we'll start by determining what is the value, what is the approximate value for the square root of 39. Well, the square root of 39 is between 49, square root of 49, and the square root of 36. Well, this is 6, and this is 7. Well, it's only 3 units away from here. It's 10 units away from here. We know it's not 6.5 because these two numbers are not equal. We know it's less than 6.5 because it's closer to 36. Okay, so it's less than 6.5. That means square root of 39 is less than 6.5. All right, square root of 29. Let's approximate that. Well, that's between the square root of 25 and the square root of 36. It's 4, this is 5, this is 6, it's 4 units away from here, and it is 7 units away from here. We know it's not 5.5 because these two are not equal. We know it's closer to 25. We know it's less than 5.5. Since this is greater than 5.5, this is greater than the square root of 29. All right, the square root of 12 is between the square root of 9 and the square root of 16. This is 3, this is 4. It's 3 units away from here, it's 4 units away from here. We know it's not 3.5. Okay, because these two numbers are not equal. We know it's closer to the square root of 9 because it's only 3 units away. So we know it's less than 3.5. So if this is approximately 3.4, well, that's less than 3.8. Okay, so the square root of 65 is a little more than 8 because the square root of 64, that's 8. Square root of 65 is a little bit more than that. So this number is less than the square root of 65. Okay, so on this page, we have a list of numbers that we have to order from least to greatest. But before we can do that, we have to convert all those numbers that are not in decimal form. We have to convert them to decimal form first. So we have to convert this to decimal form, and we have to convert this to decimal form. Let's do that first. All right, so 1, divide that by 8. All right, so 1 goes into a 0 times. So let's go ahead and add a 0 here, put the decimal up here. 8 goes into 10 one time. 1 times 8 is 8. Subtract, and we'll have 2. Add a 0 and bring that down. 8 goes into 20 2 times. 2 times 8 is 16. Subtract, that'll give us 4. Add a 0, bring that down. 8 goes into 4 5 times. 5 times 8 is 40. Subtract and get a decimal. So our answer is 0.125 for the value of 1 over 8. Okay, what about the square root of 5? That's between the square root of 4 and the square root of 9. This is 2 and this is 3. It's 1 unit away from here. It's 4 units away from here. We know it's less than 2.5. And it is very close to 4, so maybe 2.2. So we'll approximate this at 2.2. Okay, now that everything is in decimal form, we can order them from least to greatest. Okay, so -2 would be the smallest number in this list because it's negative. Then it would be 1/8. Then it would be the square root of 5. And then it would be 2.4. Remember, when you order them from least to greatest, order the numbers in their original form. So you see, I didn't put 1.25 because originally it was a fraction. So you order them in their original form. All right, let's go to the next one. 7/2 is 3.5 in decimal form. 5/2 is 2.5 in decimal form. Square root of 10 is between the square root of 16 and the square root of 9. This is 3 and this is 4. It's only 1 unit away from here, 6 units away from here. So it cannot be 3.5. It cannot be 3.5. It's less than 3.5. It's very close to 10 is very close to 9. So it's going to be about maybe 3.2. So we'll approximate this at 3.2. All right, now I can go ahead and order them from least to greatest. This is our negative number, so that's our smallest number, 4.8. And then it will be this number here, 2.2. So I got this one, I've got this one. And then it will be this number here, 2.5. And then it will be the square root of 10. And then 7/2. All right, here's 2 more examples. I want you to pause the video, work these on your own, and come back and check. I'm going to go ahead and continue. So this is 0.25 if we convert that to decimal form. This is our negative number. It's the smallest number, so I don't really have to do any work. I know it's the only negative, and it's the smallest number. And then I have 1/4 after that. The square root of 7, let's see what that is. The square root of 7 is between the square root of 4 and the square root of 9. This is 2, and this is 3. It's 3 units away from here. It's 2 units away from here. So it's more than 2.5, so this is approximately 2.6. Okay, so our next number would be 1.7, and then the square root of 7. Okay, so this is a little bit more than 8. Square root of 69 is between this 81 and 64. This is 8, and this is 9. It is 5 units away from here. So we know, and it is farther from here. It is 12 units away from here. So we know square root of 69 is close to square root of 64. So we can approximate this. We know it's less than 8.5. So we can approximate this to be approximately 8.4. All right, so, and this, square root of 36 is 6, square root of 9 is 3. So that gives us 2 for this fraction here. So then our smallest number is the square root of 100. And then this one here, because that gives us 2, square root of 36 over 9. And then square root of 69, and then 8.5. And this concludes this lesson on approximating irrational numbers and ordering and comparing numbers.